So it says consider the differential equation dy dx equals y squared over x minus 1. On the x-axis provided, sketch a slope field for the given differential equation at the 6 points indicated. So we have these 6 points identified: 0, 0, 0, 1, 0, 2, 2, 0, 2, 1, and 2, 2. So you're going to take each of these order pairs, insert into the differential equation into your derivative. In return, you'll get a number, and you're just going to interpret that number with either a positive slope, a zero slope, a slope undefined. Let's say positive, negative slope, zero slope, slope undefined. So 4 options. Okay, try that. So we're taking each of the order pairs, inserting it into our derivative equation. We're going to get a number in return, either a positive, a negative, a 0, or undefined. 0 would be horizontal line. Positive slope, we see that at 2, 1, and 2, 2. Negative slope, we see that at 0, 1, and 0, 2. Slope undefined just means that if you get a 10 over 0 or a non-zero divided by 0, you'll leave that space blank. Okay, do not put a vertical line there. You have to leave it blank. In this case, we don't have any slope undefined, not at those points indicated. Okay, any questions there? Okay. Part B. Let y equals f of x be the particular solution to a differential equation. Write the equation for the tangent line at x equals 2. Use your equation to approximate f of 2.1. So this goes back to topics that we've seen in the past. So it's asking for a tangent line equation. So what information do we need to write a tangent line equation? We need what? Slope and order pair. Yep. So this is your derivative. This is where your slope is going to come from. Think of this as your quote unquote f prime. It looks a little bit different, but it's basically is your f prime. That's your derivative formula, a derivative function. Okay. We're trying to find a replacement for m, for x of 1, and for y sub 1. They give you order pair 2, 3. So That's the starting point. Slope, we want the slope at this point. Plug slope into your derivative to get your slope value. We have our point, we have our slope. What's slope form? Any questions up to this point? So the next part is, it says, use your equation to approximate f of 2.1. So what do you think we're gonna do with this? Yeah, 2.1 in for what? X, yep. So that's all you're doing. Tangential equation, this is linear approximation. All that means is take the X value that they give you, put it into the X, and get an approximation. Okay. Typically, I like to solve for Y just to make it a little bit cleaner here. So I'll say that Y is equal to f of 2.1. So just insert 2.1 in for X. You can actually, this is actually a non-calculator question. You can actually leave your answer in this form to be fine. Okay, so this is sufficient, especially without a calculator. Okay, so tangential equation again, use the derivative to get to your slope, take your order pair, point slope form. Okay, so then part C, find the particular solution for y equals f of x to the given differential equation with the initial condition f of 2 equals 3. So we're going to go through the process that we've been doing, right? Cross multiply, separate the variables, take the antiderivative. The C shows up, and then you can decide when you want to solve for C, either beginning or the end, but ultimately we want to solve for y, get y by itself, and get the C replaced using the order pair. Right? What do you see out of place? The dy dx are good to go. Those are set. But do we have full separation yet? Not yet, right? The y squared has to move where? Denominator of the left side. The x minus 1 has to move where? Denominator on the right side. So they're both going to swap places, and they're both going to end up in the denominator of the other side. Okay, full separation. Y is on the left, x is on the right. And guess what rule we have to use for this one? Good. Y is a non-natural log. It's squared, right? If it's y to the first power, that's perfect for a natural log. But if it's any other power, we got to bring it up and go through power rule. This side, we got to go through a little bit of what? Use substitution, but it's going to end up being what? 1 over u, which is natural log, right? Now the left side is kind of like in a strange place. I want to solve for y, but right now it's kind of stuck in the denominator. What if I cross multiply it again and just try to get y by itself that way? Now, if I divide a natural log of x minus 1 plus c over, it's a mess, but at least I get my y by itself. Okay, let me solve for c, take my order pair, 2, 3. Do it for x, 3 it for y. Natural log of 1 is 0. Three equals negative 1 over c. Cross multiply, 3c equals negative 1, c equals negative 1/3. Put the negative 1/3 back where you made your substitution. So this is acceptable. What you could also do is you can multiply the top and bottom by 3 to get rid of that fraction. Makes it a little bit cleaner, but either would be acceptable. Okay. Any questions here? All right, let's go to the back. Also tangential line equation, also differential equation, but I want us to become more familiar with problems that don't have x's and y's, right? Just kind of getting used to those problems that don't have those variables that we are more familiar with. Okay, back page. We're just going to do parts A and C. Let me read the problem here. At time t equals 0, a boiled potato is taken from a pot on a stove and left to cool in the kitchen. The internal temperature of the potato is 91 degrees at time t equals 0. And the internal temperature of the potato is greater than 27 degrees for all time t equals 0. Don't have to worry about this. This is built into the formula. The internal temperature of the potato at time t equals t minutes can be multiplied by the function h that is satisfied by the differential equation. Again, this is the derivative formula here. That's our slope formula, where h of t is measured in degrees and h of 0 equals 91. Write the equation for the line tangent to the graph of h at t equals 0. Use this equation to approximate the internal temperature of the potato at time t equals 3. So it's the same process as the previous problem. We're going to create a tangent equation. We're going to get order pair. We're going to get slope. We're going to get that tangential equation built. And then we're going to use that tangential equation to approximate what happens at 3. Same process as before. It's just that instead of x and y, we're dealing with t and h. And instead of plugging in a decimal at the end, they're going to ask us to plug in x, a whole number value. But it's the same exact process. It just looks more complicated because you're seeing variables that is not as familiar. But I want us to just understand the exact same process. So one thing that we have to be accustomed to is that instead of x and y, what are our variables that we're working with here? But so x is kind of like the t, and the y is kind of like the h. Yeah, so we have to kind of get used to that. Instead of x and y, it's t and h. So what that means is our equation of tangent line looks a little bit different as well. Normally it's this. But how can we adapt this using the variables that we see here? Yep, h minus h sub 1 is equal to m times what? T minus t sub 1. So we're just trying to find a replacement for h1 and t1, and also for m. Same process, it just feels more complicated because we're looking at variables that we're not familiar with. Okay, so our order pair is, what's the order pair that we can use? 0, 91. Yep, that's our order pair. That's our T1, H1. And how do I find the slope? Slope formula, right? Just plug into dH/dt. Looks like the only variable that it needs is what? The h, right? So I can say dH/dt at 0.91. It doesn't have a t variable that it needs. It only needs the h variable. So 91 minus 27 divided by 4 divided by -4 gives us -16. Okay, so there we have it. Everything that we need is here. Here's our tangential equation. What? 91 is equal to -16 e minus 0. Instead of solving for y, we're going to solve for h. Let's get h by itself. So we have our tangential equation. So now how can we use it to approximate the temperature at t equals 3? Yep, plug 3 into t and solve for h. Okay, let's do part C. Part C is its own thing. It says for t squared less than 10, an alternate model for internal temperature is given by dg over dt, where g of t is measured in degrees Celsius and g of 0 equals 91. Find an expression for this g of t based on this model was the internal temperature at time t equals 3. So Same, we're gonna go through our process, separate our variables, solve for C using this order pair. And once we have our specific solution, then we can use that to help us figure out the order pair at 3 or the internal temperature at 3. This, you may need a little bit more room. So if you feel like you don't have enough room, you can go to the next packet, page 26. I have a blank page there, or any blank page that you'd like if you want more room. So we don't see X's and Y's. We see T and G. So T will treat it like what? Like X, and G will treat like as if we're looking at Y, right? So, okay, so first things first, let's cross multiply. Okay, dg and dt are set up. Those are nicely set. What's out of place? So what do we have to move? Yeah, the whole parentheses, right? But what can we keep on the right side? The negative, right? The negative doesn't have to come over. We only want to bring over what is necessary. So I'll divide the g minus 27 over and the 2/3. So all that is stuck together. Okay, now we have full separation. G's on the left, T's on the right. Right side is easy. We can just go through what for the right side? Power rule. But the left side, we got to go through what? Use substitution. What's G minus 27's derivative? Just 1, right? Yeah.
Right. Why don't you do the entire thing?
Because remember, if we want to find the U value, it's always what's inside the parentheses, right? We always only want what's inside the parentheses most of the time. Okay, here's the cleanup. Haven't done the right side yet. I wanted everything lined up. Now here, we have U substitution. Everything is nice and clean, but what rule is necessary for this setup? Power rule or natural log? Good, power rule, right? I know that U in the denominator is tempting you to go through natural log, but this is not an exponent of 1. That's a different exponent. We got to bring it up. We got to go through power rule. With the power rule, U to the negative 2/3 becomes U to the plus 3 over 3 is negative 1/3 over negative 1/3. Negative 1 dt becomes negative t plus c. Once you have your antiderivative, we can bring our original variable back. Yes, sorry, positive 1/3, plus 3/3. Thanks. Now it's kind of arbitrary decision here. I just decided, well, this feels like an easy place, or I mean, it's the easiest it's going to get before, because I got to divide by 3. I got to cube both sides. So I figured maybe I can just solve for C, just to get that over with. But but it's always an arbitrary decision. I should look to see, okay, is it going to get any cleaner? So basically you can solve for C at any moment in time. As soon as it shows up, you can solve for it. But ultimately, you have 2 goals. You're trying to solve for C, and you're also trying to get G by itself. Okay. So it doesn't matter which order you do them in, as long as we should be in lockstep up to this point. But after that, everyone can take a different step or different order. So there's my order pair that will help me solve for C, 0 in for T, 91 in for G. Okay, 91 minus 27 is 64. Cube root of 64 is 4. 4 times 3 is 12. Okay, I'm going to reset. Go back to where I started making my substitution. Plug 12 in for C. And then I'm just trying to solve for G now. One by one, I'll move things over to the right side. Okay, what can I do to get rid of the parentheses? Raise both sides to what power? Third. Add 27 to both sides, we have G. So there's my G equation. Finally, it's asking us to figure out, based on this model, what is the temperature at T equals 3? So just plug 3 in for T and find G. This is negative 3 plus 12 is 9. 9 over 3 is 3. 3 cubed is 27. 27 plus 27 is 54. Okay, last one. I want us to go to the packet that you guys just picked up, and we're just going to do number 1. So we're gonna find a particular solution. Don't worry about the domain yet. Find the equation tangent line and use the linear approximation. So we're gonna cross multiply. Take the antiderivative plus c shows up. Take the order pair. If you feel like you need additional room, I have some scratch sheet here. So it's up to you. If you like it. And keys on the next page, so you can kind of move ahead if you're ahead of me. Okay, one thing is out of place. What's that? X squared. So we do what? Divide. So it's going to end up in the denominator. Okay, left side, we're going to use what rule? Power rule. Right side, we'll use what? Also power rule, right? That x squared needs to come up to the top. We got to go through power rule on the right side as well. I'm going to resolve that too before I solve for C. That's just my preference, but you could definitely solve for C earlier if you'd like. Make my substitution back in. Almost there. Take the square roots. Okay, these are two solutions here. Which one do I choose? Because y is negative. Yep. Okay, find the tangent line equation. So this is a separate process here. So again, tangent line equation, we need what? Order pair and slope. Order pair is this given information. And how do we find the slope? Into the derivative, right? Here's your differential equation. That's your derivative formula. That's all we need. Okay. We're not going to use this anymore. This is not part of the process, not for tangent line equation. All right, part C. Right, that's all we need. Order pair, slope, point slope form. And how do we do the last part? Last part says use it to approximate y of negative 1.1. So negative 1.1 and for x, yep. But the thing that I want to keep reminding us is this process we know how to do. I know the derivative looks a little bit different, but it's still a derivative. It's a little messier because then x's and y's in it, but it still serves the same process as prime in the first semester. We're just having to plug in both x and y values to find slope, but it still does the same thing. All right, we'll continue test review after you guys get back from break. We're just going to work through the rest of the packets for test review. Okay. All right, complete the folks.